All right, hello everyone. Today we're going to be learning about instrument approaches. This is Unit 22. Okay, so today, instrument approaches, we're going to be going over, as an overview, we're going to be discussing an introduction to instrument approaches. We're going to talk about the different approach types that you're going to come across, as well as the different approach segments of an approach. So it should be a pretty straightforward lesson today. So here are our objectives. The student will describe the different types of approaches, understand pilot, weather, and aircraft requirements for different types of approaches, describe the stages and points that define an approach, interpret an approach plate and determine required pilot actions, understand different approach types and categories. Airman Certification Standards, Task 5B, we have departure, en route, and arrival operations. The applicant demonstrates an understanding of elements related to ATC routes, including instrument approaches procedures. Task 5A through E discuss the non-precision, precision, missed, circling, and landing from an instrument approach. So all the things you have to know there. References were out of the IFH Instrument Flying Handbook, chapters 1, 9, and 10. The Instrument Procedure Handbook, chapter 4, talking about approaches, and then the AIM, chapter 5, Air Traffic Procedures. So again, those are our references if you would like to go more in depth, and then as well as if you would like to get more additional information, you can go out and get the ASA Pilot Manual, chapter 29. So let's talk about an overview of approaches. There are a couple of different type of approaches that we learn about. The first of which is precision approaches. And so I guess I should say the big two approaches that we talk about are precision approaches as well as non-precision approaches. A precision approach is an ILS system. So as we've discussed in the past, an ILS system gives you two things. It gives you lateral guidance and it gives you vertical guidance. So remember that's with the localizer and then the glide slope indicator. And these are certified runways according to CFR Part 77. So that is a precision approach. Precision approaches, think, obviously the word precision kind of helps you remember what you're getting with it. It's helping you get down to a very low altitude before you have to make that decision. So with precision approaches, you can have very low weather minimums. The clouds can be typically around 200 feet AGL. So it gets you very low to the ground. Non-precision approaches only give you lateral guidance. So this is only using a localizer of some sort, VOR, etc. So yeah, here we have, you can see localizer, LDA, SDF, VOR, NDB, LNAV, and ASR. So there's lots of different types of equipment that can give us non-precision approaches. For you guys, you're going to be most familiar with the localizer, the LDA, the VOR, and the LNAV. Some of these other technologies aren't as common. And then there is a third type of approach, which is kind of in the middle here, which is approaches with vertical guidance. And this is where things can get confusing because they're very similar to precision approaches because you have both lateral guidance and vertical guidance. So there's a couple different ways we can get this. Sometimes you can have an LDA. So remember that's a localizer that's not aligned with the runway plus glide slope. You can have LPV, which is localizer performance with vertical guidance. So you get something very similar to a precision approach. And then you can have LNAV and VNAV. LNAV is lateral GPS guidance and VNAV is vertical GPS guidance. So you can see how with these, with lateral and vertical guidance, you can almost get a precision approach. And in some cases, some LPV approaches will get you down to 200 feet AGL, just like a precision approach will. So they're very similar, but there are some differences that you have to be aware of. So if I will, I can't remember if I've published these PowerPoints to you guys or not, but I put a link here. There is a Bold Method article that I'll make this slideshow available when I post it. And if you click on this link, it'll bring you to a Bold Method article that talks about approaches with vertical guidance so that you can just kind of read and understand what the difference is with all of these different types of approaches that give you good vertical guidance but aren't considered precision approaches. Okay, let's talk about the different types of approaches. So we have visual approaches, we have vectors, we have contact approaches, and then we have instrument approach procedures. These first three are very straightforward. There's not a lot of content there. They're pretty simple. And looking at the names, you can pretty quickly get an idea of what they are. The instrument approach, the IAP, is what takes a lot of time. You have to practice them. A lot of information there, so that's the bulk of this lesson today, is talking about the instrument approach procedures, but we will talk about visual, vectors, and contact. So first off is the visual approach. This is the easiest and most efficient type of approach that we have. It is what it says it is. It's a visual approach. This means you're on an IFR flight plan, you've come up to the airport, and it's sunny and blue skies, clear of clouds. Or more appropriately put, the ceilings are greater than 1,000 feet AGL and the visibility is greater than 3 statute miles. So that means we have VMC, vertical meteorological conditions. So essentially you would approach the airport, you would be listening or get the weather information and you would find out, hey, I have VMC. So you would request a visual approach. So that means you essentially leave the IFR flight rules and then you just fly into the airport like you would a VFR pilot. You have to remain clear of clouds, you have to fly direct to the airport, and you have to maintain visual contact with the airport at all times and any preceding aircraft. So it's pretty straightforward, and this is what you want. If you're on an IFR flight plan and you get to an airport and the weather allows it, you should request a visual approach because it's the easiest. Next, we have a contact approach. A contact approach only a pilot can initiate. So only a pilot can ask for this. They can ask for a contact approach. In this case, they must remain clear of clouds. The visibility must be greater than or equal to 1 statute mile. And the airport must have an instrument approach procedure in case something goes wrong. So let's say there's low clouds in the area, but maybe they're spotty, and you know that you can visually make it to the airport without having to do an approach procedure. You can request contact approach. So ATC can give you maybe vectors to get you close, and then once you have the airport in sight, you can use that contact approach. So now let's talk about an actual instrument approach. So this is the IAP, instrument approach procedures. So those other procedures, the visual, the contact, pretty straightforward. But an actual approach procedure, instrument approach procedures start to get complicated. And this is where this is the bulk of your instrument training, is learning how to fly approaches because they're complicated. The en route stuff, the departure stuff is pretty straightforward. The other phases of instrument flight are very simple compared to the instrument approach procedures. So in any instrument approach, you're going to have a couple of different segments. First, we have our feeder route, our initial approach, our intermediate approach, the final approach, and, if necessary, the missed approach. So the feeder route is what gets you from your en route segment to the initial approach fix. So this is kind of the transition. You're going from the low en route chart to now you're looking at an approach plate, an actual instrument approach. The initial approach, or the initial approach fix, is what kind of, you can consider this like the starting point on an instrument approach. This will take you from your IAF, or initial approach fix, to your intermediate fix. And a lot of times this will include the course reversal, depending on which direction you come from. Then next we have the intermediate approach. This takes you from your intermediate fix to your final approach fix, which then starts you on your final approach. So this takes you from your FAF down to the runway. So this is a final approach. Think of like in a VFR flight when you're on final for the runway, you're lined up with the runway, you're now preparing to land. So the FAF, or the final approach fix, down to the runway, or the missed approach. So let's say you don't have the runway in sight, then you would execute your missed approach. And then missed approach is MAP to the hold. So there's typically a hold after a missed approach. So let's talk about each portion of the approach segments. First is the feeder route. Again, the feeder route is what takes you from your en route structure to your initial approach fix. So this is how we kind of get established in our approach from the en route sector. So over here, you can see we're looking at the low en route chart. Here we have the Clovis VOR, and this is kind of the start, or where we're expected to start from, to get us into Fresno Chandler Executive. And then you can see the parallel over here on the right-hand side. This is our approach plate. So this is an approach plate, the VOR DME, or GPS-C, into Fresno. Okay, and here again, you can see the Clovis VOR. So you can see the parallel between the en route chart and the approach plate. So this is our feeder route. When you're looking at the approach plate, you know it's a feeder route because there's nothing, there's no names next to this fix. So Clovis is a VOR, and you notice it doesn't say IF, it doesn't say IAF, it does not say FAF. So that's how you know because it doesn't say any of these things. That's how you know this is kind of your feeder segment. So Clovis is getting us established to the initial approach fix. So if we look at this plate, we would then look for, okay, if I'm going from Clovis down the, was that the 167 radial, where's my initial approach fix? So if I keep following it all the way down, I can look down here and see here's my initial approach fix. So there's actually 3 initial approach fixes. So if you'll notice, this approach includes a DME arc. So you could get sent to any 3 of these initial approach fixes. You could arc from the east here, you could arc from the west, or you could do a procedure turn, which we'll talk about in a second. So there's lots of ways you can start this approach. There's lots of approach fixes, but we'll talk about the IAF in a second. So anytime you see an approach plate that has a fix guiding you to the IAF, that is your feeder route, or your feeder segment. Some feeder routes have what we call terminal area or terminal arrival areas. So looking at the RNAV GPS runway 21 left into Prescott, you can see that Payview is the initial approach fix. And here we have that terminal arrival area. Now, because it's an RNAV, a lot of times people will be flying direct. So there isn't necessarily a established feeder route. pilots can fly direct to the initial approach fix because it is GPS or RNAV. So depending on which direction you come from determines the procedure or the feeder route procedures that you will follow to get to your initial approach fix. So here is kind of a diagram that shows there's PayView, and here's kind of an overview of PayView. So this right here, this, what I'm circling right now, that is not the actual approach fix. Initial approach fix. This, where I'm drawing my arrows, this is the initial approach fix. So this over here is kind of just a diagram showing you, depending on which direction you come from, you can see here it's divided by the 118 inbound and the 298 inbound. 118 inbound, 298 inbound. So if you're generally coming from the southwest or the northeast, it determines your procedure. So if you're coming from the northeast, 30 nautical miles out from PayView, you would descend down to 11,600. Once you're 10 nautical miles out, you begin descending down to 9,100, and then you would fly the initial approach fix. Over here, I have kind of I've taken the approach plate and I've overlaid it on top of the en route, and they're kind of scaled to the same size. So you can see what that looks like, how the en route and the approach plate compare. It's kind of hard to see, there's the green airport with the actual airport on the approach plate kind of overlaid. So you can just get an idea. Some of these approaches really take you out, can start out pretty far when compared to that en route chart. So just something to kind of keep in mind. And it kind of clues you into why certain altitudes are chosen, especially for the en route segment and the approach plates, so that we can keep this traffic separated. So anytime you see an MEA on a Victor airway that's close to an airport, and you wonder, well, why is that MEA so high? That feels unnecessary. And it's because there's potentially approaches that are being operated just under that MEA. So something to consider when you're flying an approach or looking at MEAs, why those altitudes exist. So for the approach segment, this is kind of what we call the profile view on your approach plate, and this is a legend telling you what each part is, just kind of giving you an idea of what each segment is going to look like if you were looking at it from the side. So it defines all the very important parts of your instrument approach. So if you ever get confused about what each thing represents, what each symbol represents, looking up the legend for an approach plate and looking at the profile view can really help you out. So this is for an ILS or localizer approach. So you can see some stuff like the differences between the final approach fix for a precision approach or the final approach fix for a non-precision approach. How they are distinguished. So a final approach fix for a precision approach, for example, it starts when you intercept glide slope. For a non-precision approach, it starts at a specific checkpoint or a specific altitude. So just things to note that a lot of times, depending on what equipment you have, you could be flying an ILS but only be using the localizer. So you have to know the differences and what those mean for you as a pilot. So some of these will begin to make sense as we look at some examples. So now that we've finished talking about the en route segment or en route to the initial approach fix, let's talk about the initial approach segment. So this is what takes you from your initial approach fix to your intermediate fix. So think of your initial approach fix as the starting point for the approach. So in this case, we're looking at the VOR, DME, or GPS-C for Fresno Airport. And this is not for a specific runway because if you look, it's kind of hard to see, this runway is at an angle. So it's not a straight-in approach. So in this approach, there are, again, 3 initial approach fixes that you can do. 2 of them are DME arcs from the west or from the east. The other one is established here at Weaver. So the Weaver initial approach fix can be used if you're coming from essentially 2 directions. If you're coming from the north here or from the south, you get established directly on that initial approach fix. Or maybe if you're coming from the east or the west, you can use that DME arc. So your initial approach fix is taking you to the intermediate fix. So this is kind of the intermediate fix is your in-between. As we look at this top-down view of this approach, you might be wondering, well, where is the intermediate fix? Because it's not published, it's not listed. A lot of times the intermediate fix or the IF will not be published because it's kind of just assumed that it's everything between your initial approach fix and your final approach fix, or sometimes they're the same. It all depends on the approach. Okay, so sometimes it's labeled, sometimes it is not. Let me see if I can real quick pull up an example. Here we're looking at the ILS or localizer DME for runway 21 left, and you can see here that the initial approach fix and the intermediate fix share the same fix. So it just depends on which direction you come from. That's why they share the same point. Because a lot of times, going back to our PowerPoint here, the initial approach fix is will be used for course reversal, depending on the direction you come from. So for example here, if I came from the north, so if I was flying from the north towards the south on this, I would have to do a course reversal to get established on final approach. So let's say I'm coming down from Clovis, I'm flying. I've hit my initial approach fix. So now at this point, I've started the approach. To truly be established on the approach, I need to turn myself around. So I would do a course reversal or a procedure turn. In this case, I would fly out and do a parallel entry technically into this hold. So I'd fly out for a minute, I would turn to the right, come back inbound, and once I was reestablished at Weaver, now I've started my intermediate fix. So that's why the IAF in this spot is also can also be considered the IF. Or if I had come from the south, I guess you consider Ikogi your initial approach fix in some ways, and then Weaver would be your initial fix. So it really is dependent on how the approach is set up. Because a lot of times you will have to do what we call a course reversal. So let's talk about a course reversal a little more in depth. So a course reversal can become 2 different things. It can become a procedure turn or it can be a holding pattern, depending on what ATC wants you to do. So let's look at 2 examples. Let's say we're doing, this is the VOR DME runway 12 into Prescott over here. So this is a VOR approach. So let's say we are coming from the south or the east. So I come up and I hit Drake. Drake is my initial approach fix. And so in order to get established, in order to come in on the runway, I need to get myself turned around. So I would fly outbound on the Drake 305 radial, and then I would do what we call a procedure turn. So this little barb up here, this is our procedure turn. So I would make a right turn and fly outbound for 1 minute on a heading of 350, and then after a minute I would turn back inbound to intercept the 125 back to Drake. And if you ever wonder which direction do I turn, you can see here we have like a half arrow on the procedure turn. We call that the barb. You always turn in the direction of the barb. So let me erase some of this so we can kind of get it clear again. Why is it not erasing? I don't know. But anyway, you would turn to the right, come inbound, intercept the 125, and then continue the approach. So that is a procedure turn. Or you can do a holding pattern in lieu of a procedure turn. So let's say we're on the same approach that we were looking at earlier. I'm starting at Clovis. This is my my en route segment. So I'm coming in on the 167 degree radial. I would come down to Weaver. This is 12.8 DME from Clovis. Then I would just enter this hold, and I would enter using the appropriate entry. So then the question is, what is the appropriate entry? Hopefully, just by looking at it, you should have a good idea of which entry we would use. We would know if I came from the south, I would just use a direct, because if I was established on the 347 course to Clovis, I would just do a direct entry. But because I'm coming from the north, hopefully it's very clear that you would just do a parallel entry. So you would fly outbound for 1 minute, then turn to the right, do a parallel entry, intercept that fix again. And at this point, ATC is either going to tell you to hold, so they're either going to establish you in the hold if they want you to wait, or you would continue from, because now this is no longer the IAF, but the intermediate fix. So they would either tell you to continue in the hold or continue down towards the final approach fix. So those are the two ways you can do a course reversal, is a procedure turn or a holding pattern in lieu of a procedure turn. So remember, the idea of a course reversal is if you are coming at the approach from the opposite side. So a lot of times you will see how an approach can be set up so that you can kind of just fly straight in. So if we look back at the VOR 12, so if I come over to the VOR 12 again, if I was already on the 305 coming from the northwest, so if I was already established, ATC would just give me a straight in. They're not going to tell me to fly to Drake and then turn around to do the procedure turn just to turn around again. Why would they tell me to turn around twice when I'm already established inbound? So if I have a course of 125 already set and I'm flying inbound on the 305 radial, they would probably just give me a straight in to the initial approach fix of Drake and then continue on. If I was on the 259 or the 349, they would probably give me the DME arcs to get in, because these are also considered initial approach fixes. So they could give me these arcs to come in, but only if I'm coming at Drake pretty much from any other direction. So basically any of this area, they would probably have me do a procedure turn or holding pattern in lieu of procedure turn. So just something to keep in mind as you're choosing approaches and runways. Try to be aware, right? You can use your logic and discern what are they going to have me do based on my direction, where I'm coming from. You should be able to peek into the future and predict what ATC is going to tell you to do based on your approach, as opposed to just waiting and seeing what they're going to tell you. It should be pretty obvious. They're not going to waste your time by making you do unnecessary arcs or unnecessary procedure turns if you can just fly straight in. So something to be aware of. Now let's talk about the intermediate segment. Remember, up till now we've been talking about the initial approach fix. So kind of starting your approach. So the initial approach fix, the IAF, took you to your intermediate fix. This happens. This is typically where your procedure turn is going to be, a hold is going to be, a DME arc is going to be. And by the way, this is what a procedure turn looks like in the profile view. So you can see in this case, it has us descending down to 9,700. Then we would do our procedure turn and get turned around so that we could fly inbound. So that's what that initial approach segment is going to look like. Unless it's a straight in, then you would just come straight in at 9,700 and descend down to 9,000. But now let's talk about the intermediate fix. I'm just going to erase some stuff real quick. So the intermediate fix is what takes us from the intermediate fix to the final approach fix. So this is the end of course reversal to the final approach fix. And it's when you have positive course guidance inbound. So we are established inbound to our runway. So as you can see here in this approach, we're descending from 9,000 to 8,800. This Maltese cross here, because this is a VOR approach, this Maltese cross, this little cross, is what tells us this is when we are established. This is the final approach fix. So once we pass this point, we are on final approach into this runway. In this case, it's runway 21. Okay, so again, always whenever you look at an approach, draw the parallels. Look for the different segments and where they line up in the top-down view and the profile view. So here you can see we have chef. This serves as our intermediate fix as well as our initial approach fix, depending on which direction you're coming from. So you can see it here. Here is chef, that 9,000. Then if we go down to Zeisig, that is our final approach fix. So here is Zeisig. So always draw the parallels. Try to figure out the different pieces, how they relate to the profile view, so you get a good idea of what you are doing for each portion of the approach. So that is the intermediate segment. And then after that comes the final segment. Okay, this is what takes you from your final approach fix down to the runway, if you're going to land, or to the missed approach point if landing is not an option, if runway environment is not in sight. So the final approach fix is two things, depending on what kind of approach you're flying. So the final approach fix is when you have glide slope intercept for a precision approach. So when you get that glide slope intercept, that is your final approach fix. Or it's the Maltese cross for the non-precision approach. So again, it is, and then that brings you down from your final approach fix to your missed approach point. And that can be one of two things. It's either your decision altitude, what we call DA, for a precision approach, or the missed approach point for a non-precision approach. So this is the profile view for the ILS or localizer to and left into Flagstaff. So the profile view is meant to show you your, it's an ILS. It's meant to primarily show you the steps for an ILS approach. So you can see here that this checkpoint here is our decision altitude. So this is where we would execute that missed approach point. This next fix, SOLB, is your MAP if you're flying the localizer. So here we have our, for precision, that's the decision altitude, and then our MAP, or for our non-precision, comes a little later. So what that would look like, there are two different points. They've charted it, think of it this way, they've charted it for the ILS. I'm going to erase some of these things here. So this approach, this missed approach point, how do I go backwards? I want to get these out of the way. So the DA, the missed approach flight path, is charted for the ILS. Now let's say you're flying a localizer. So you're not using the full ILS, you're flying the localizer. So this has a higher missed approach point, or missed approach decision altitude, I should say. You can see that it's higher than in the ILS. So what you would do if you were flying this is you would descend down until you hit that altitude, and then you would fly level until you get to SOLB. That's why it's charted closer to the runway so that you have more time to get the runway environment in sight. If not, then you would execute the missed approach procedures. So that is the final segment of your approach. So again, the precision comes first, and then the non-precision comes second, if you're looking at an ILS or localizer into an airport. And then the last step is the missed approach. So this is what happens if you come into land, you do your approach, it's perfect, except once you get down to that decision altitude or that missed approach point, you do not have the runway environment in sight. So in this case, we cannot continue the landing. We have to go missed, or do a missed approach. So we do an MAP to en route or to a hold. So in this case, we're looking again at runway 21, the ILS runway 21 into Flagstaff. At the top, there is a description of the missed approach. So this is at the top of an approach plate. So it says once you hit that decision altitude and you don't have the runway in sight, you're going to start by climb to 7,500. Then once you hit that altitude, make a climbing left turn to 11,000 on a heading of 130. And the Flagstaff radial 172 to the Oates intersection of the Flagstaff VOR DME 16.7 DME and hold. And then continue to climb and hold to 11,000. So that description can get kind of confusing, so we just come over here and look at our map view to figure out what that means. So you can see here this dashed line represents our missed approach procedure. So again, I'm going to hit that missed approach point, go straight out, climb to 7,500, then make a climbing left turn to 11,000 on a heading of 130 to intercept the 172 degree radial. Once I do, I'm going to fly that radial outbound till I hit the Oates intersection. So here you can see they have this little box that shows the missed approach fix farther out. So I'd fly to Oates, which is 16.7 from Flagstaff. and then I would hold. So in this case, again, hopefully by looking at it, whenever we approach a hold straight on, so in the exact opposite direction of the inbound leg, I would just use a parallel entry into the hold. And then I would hold and climb to 11,000. Then I would wait for further instructions. So I would wait to see what ATC tells me to do. So that is a missed approach procedure. So it's always written textually and shown graphically. And then once you're established in that hold, they're going to tell you, ATC will tell you what to do. So they're either going to give you a different approach, or for maybe a different runway that has different approach minimums, or you're going to have to go to your alternate. So let's put all of the pieces together using the runway 21 left into Prescott. So first, let's say we start at Drake. We would fly from Drake towards the initial approach fix using our feeder route. So in this case, once we hit our initial approach fix at Crotty, hopefully you're noticing that we're going the opposite direction than we need to be in order to fly this ILS. So what should we do in this case? We need to make a course reversal. And for us, our course reversal is going to be a hold in lieu of a procedure turn. So I'm going to fly a parallel entry into that hold. So one of two things is going to happen. So now you can see, so hopefully you're looking at both our top-down view here, see that we're making that procedure turn, and the same thing is happening over here in our profile view. So the two things are happening in tandem. So one of two things is going to happen at this point. ATC is either going to tell us to stay established in the hold, so we're going to hold until they tell us not to, or they're going to tell us to continue with the approach. So we did our procedure turn, our hold in lieu of a procedure turn. We did our course reversal. So now we're heading the appropriate direction. We're now moving away from our initial approach fix. Now we're on the intermediate fix. Okay, so here we have our intermediate segment. So you can see the two intermediate segments on the top-down view and our profile view. And that's going to take us down to our final approach fix. So in this case, if you're doing a precision approach, if you're on the ILS, your final approach fix is when you have glide slope intercept. And once you have glide slope intercept, you're going to take that down to your decision altitude. So here we have the green represents our final segment. So we've passed our final approach fix at Humpty, and now we're on our final segment down to our runway. So one of two things is going to happen. We're either going to land if we have visual confirmation of the runway, or we're going to go missed. So let's say if we do the missed approach procedure, we would start to climb. We would climb towards Drake. And in this case, we wouldn't initially hold. We would keep climbing. We would fly outbound on the 305 degree radial, make a procedure turn back inbound, and then we would hold. Hold as published. So that's kind of putting all of the pieces together. So here is an approach activity. Again, we would have done this in class. I would like you to do this on your own. I would like you to find a precision approach, and I would like you to find a non-precision approach. And I would like you to identify altitude and location of all of the different segments. The feeder route, the initial approach fix or your initial segment, your intermediate fix or the intermediate segment, the final approach fix, the final segment, and your missed approach. Okay, so practice now. Find a precision approach, find a non-precision approach, and identify the different segments. Maybe you can use your iPad. In ForeFlight, you can change the color. So maybe do the same thing. Use blue for your initial segment. Your intermediate segment is red. Green is your final segment. And then missed approach, maybe make a different color. So that you can begin to identify all of the different parts of an approach, so that you can just get familiar with going back and forth between your top-down view, your profile view, and understanding how the approach works. And also paying close attention to things like altitude. Okay, so if you can do that for practice, that would be great. Again, this is something we would have done in class, but I would love if you guys could practice this. And if as you go through this, you get confused, you can always reach out to me for questions. So again, as always, you can email me. You can hit me up on Canvas, the Canvas messaging. And then if you need further guidance, we can always set up a Zoom call and we can go over these problems together. So let me know what you think. Let me know if you need help. I am always available to you. And I will see you guys next time.